On a clear afternoon, it can feel like the sun is beating down, especially here in New Orleans. But what exactly causes this feeling? The sun in our solar system is one of the keys to supporting life on Earth. And it accomplishes this task is by holding Earth in constant gravitational orbit, keeping Earth at just the right temperature and providing energy for plants to grow, which provide the base of the food chain. The sun emits three kinds of energy waves: visible light, infrared waves, and ultraviolet waves. Almost all UV rays are absorbed by ozone and oxygen in the lower stratosphere, which protects humans from UV damage such as skin cancer and eye problems. Trees' leaves are also sensitive to UV rays and are protected by the ozone layer. The energy that reaches the ground is visible light, which organisms such as humans use to see, and infrared waves, which provide heat.
For thousands of years, humans have recognized the life-giving power of the sun. Ancient pagan religions had gods that represented the sun, and many would hold religious festivals at the winter and or summer solstices as a way to celebrate the harvest or show thankfulness to the sun and ask it to return again after the shortest day of the year. Today it's understood that the sun will always come back after the winter solstice, and humans have made significant gains in research and technology to harness the power of the sun. Currently, the most common method of capturing the sun's energy for conversion and use as electricity is with photovoltaic cells or PV cells. These cells use a process known as photoelectric effect to absorb the photons in sunlight and release excess electrons, which are then captured and used to create an electrical current. Edmund Becquerel first discovered the photoelectric effect in the early 1800s, and the technology was slowly developed over the next century. Bell Laboratories unveiled their solar battery as a very expensive novelty in 1954.
PV cells are commonly made from a material called polycrystalline silicon. First, the polysilicon is obtained from quartz, then melted down. After a small amount of boron is added to help with conductivity, the liquid polysilicon is poured into a black mold. After it's hardened, thin slices are removed from the block and are etched for assembly. The slices are then cleaned and placed in a phosphorus diffusion furnace to create a semiconductor layer around the entire surface of the solar cell. Finally, electrical contacts are placed on the positive and negative sides of the cell, anti-reflective coating is applied, and the cell is tested. After testing, several cells are wired and mounted together on a frame called a photovoltaic module. Modules in turn can be wired together to form an array.